Hi everyone, in this video we're going to look at another example where we're told to sketch the graph of g of x. And the first thing that we're going to do is we're going to identify the parent function. So it's quite obvious here that the parent function is f of x is equal to 1 over x. The next thing that we're going to do is we're going to see if we can simplify g of x at all. And notice that if we rewrite g of x, if we factor the k value in the denominator, we can rewrite g of x is as minus 2 over 4 times x plus 2 minus 3. And we can now divide out a factor of 2. Because 2 and 4 are both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So we can rewrite g of x as minus, we can write it as minus 1 over 2 times x plus 2 minus 3. So next, let's go ahead and identify what our a value is, what our k value is, what our d value is, and what our c value is. So here, this question's a little bit interesting because there's actually two different options for what k is and what a is. So here, notice that if I look at what transformations have been applied to the parent function, I can think of this as my a value being equal to minus 1/2, because I can think of this as multiplying, I can think of g of x as being f of x multiplied by negative 1/2, and then I can, I've added 2 inside my function f of x, and outside of the function I've subtracted 3. So a is going to be equal to negative 1/2. If a is negative 1/2, k has to be equal to positive 1. D is going to be equal to negative 2. Remember that I always flip the sign on D. And C is going to be equal to minus 3. So now I can go ahead and I can think about what the key points of the parent function are, and then I can go ahead and use the mapping rule to figure out what the transform points of this function are. So let's go ahead and we'll write out the key points of the reciprocal function. So we've got x comma y. And the key points are minus 2 comma negative 1/2. I've got negative 1 comma negative 1. I also have negative 1/2 comma minus 2. I have 1/2 comma 2 and 1 comma 1, as well as I have 2 comma 1/2 on the graph of my parent function. So these are all the key points from the reciprocal function. And if you don't remember these, I suggest that you review the videos that I've posted on parent functions. So now we can go ahead and we can use the mapping rule to transform all of these points. Remember that the mapping rule says that if x comma y is on the graph of f of x, then on the graph of a times f of k times x minus d plus c. So on this graph here, the transform coordinate will be x over k. So here I've got x divided by k, but k is just 1, so x divided by 1 is just x. And then I have to add d. d here is negative 2, so I'll have x minus 2 being my new x coordinate. Let me write that so that it's a little bit, okay, there we go. Okay, so I've got x minus 2, and then I've got normally ay plus c. So a here is negative 1/2, so I'll multiply my y value by negative 1/2, and then I'll add c, but c here is negative 3, so that's the same thing as negative 1/2 y minus 3. So we'll go ahead and we'll plug in each of these x and y values into my coordinate formula. And I'm going to get, let's see here, negative 2 minus 2 is minus 4. Negative 1/2 times negative 1/2 is positive 1/4. Positive 1/4 minus 3 is minus 2.75. And then this coordinate transforms to, well, I've got -1 minus 2, which is minus 3. And then I'll have minus a half times -1, which is positive 0.5. Positive 0.5 minus 3 is going to be negative 2.5. I also have negative a half minus 2, which is minus 2.5. And then I've got negative a half times negative 2, which is positive 1. Positive 1 minus 3 is minus 2. So notice that here I've got decimals that are exact values, but if I had, say like division by 3, like let's say I had 1/3, I should definitely leave this as a fraction, because as soon as you round 1/3 to like 0.3 or 0.33, you lose accuracy unless you add the bar above the number that, or the digits that are repeating. So definitely, if you have to round, leave it as a fraction. Okay, next we have 1/2 minus 2, which is minus 1.5, comma, I'll have 2 times negative a half. 2 times negative a half is minus 1. Minus 1 minus 3 is minus 4. Then 1 comma 1, I have 1 minus 2, which is minus 1, comma, negative a half times 1. Negative a half times 1 is negative 0.5. Negative 0.5 minus 3 is negative 3.5. And then I also have 2 minus 2, which is 0, and negative a half times a half, which is negative 0.25, minus 3 is negative 3.25. Whoops. Minus 3.25. Okay, so the next thing that I would recommend doing is, here we should definitely, especially as we're just getting the hang of graphing functions and graphing transform functions, I would definitely recommend to graph the parent function. So let's go ahead and we'll graph the reciprocal function, which is the parent function. And if you recall, the parent function has a horizontal asymptote at y is equal to 0. It's got a vertical asymptote at x is equal to 0. So let's go ahead and we'll draw the vertical asymptote at x is equal to 0. We've got key points -1, comma, minus 1. I've got a key point at negative a half, comma 2. A key point at minus 2, comma, negative a half, which is right here. Then I'm just going to draw a smooth curve through these key points. And after these key points, my graph just keeps approaching the vertical asymptote. But it never touches the vertical asymptote or the horizontal asymptote. So it keeps getting closer and closer, but never touches the vertical or horizontal asymptote. So let's go ahead and we'll graph the key points on the other side of the graph, or in the first quadrant. I've got a point here, a point here, and a point here. And we can go ahead and we can sketch a smooth curve through these points. And then after these key points, my graph just keeps approaching the asymptote. But again, it never touches. So this is the graph of y is equal to 1 over x. So now let's go ahead and we'll graph our transform function. And anytime that you're transforming a reciprocal function, the first thing that you should always do is think about where your asymptotes are. So you can do that by identifying what translations have been applied to the parent function. So I know that since d is equal to -2, I have a horizontal translation 2 units to the left. So that means my vertical asymptote will be at x is equal to -2. So that's my vertical asymptote, x is equal to -2. I also have a horizontal asymptote that has been translated 3 units downward. So I've got a horizontal asymptote at y is equal to -3. So that's my horizontal asymptote, y is equal to -3. Okay, so now I have to figure out where these points are on the graph. So I've got a point at -4, -2.75. So -4 is, let's see here, -1, -2, -3, -4, and -2.75 would be right here. So I've got a point on my graph that's there. I have another point at -3, -2.5, which is here. And I have another point at -2.5, -2, which is right here. So you can kind of see that these 3 points got transformed to this location here, or sorry, these three points right here. So I'm going to go ahead and I'm going to sketch a smooth curve through these 3 key points, and then I'm going to go ahead and my graph will continue to approach the asymptote as we get larger and larger x values. And as we go x values further in the negatives, my graph will continue to approach the horizontal asymptote. So my graph's going to look something like this. So it's going to go that way, and then it should go this way. And this is the graph of g of x. It's not complete yet because I have to graph the points that are on the other side of the function, or on the other side of this point, or these axes here. So I'll have another point at -1.5, -4. So -1.5 is right here. -4 is here. Whoops, sorry. -1.5 is definitely not there. -1.5 is here. -4 is right here. And then I've got another point at -1, -3.5. So -1, -3.5 is here. And then I'll have another point at 0, -3.25. So I've got another point at 0, -3.25. So I have another point here. So now let's go ahead and we'll sketch a smooth curve through these key points. And again, after the graph passes through these key points, the graph approaches the asymptotes. Oh, it should get closer. I missed. I'm not a very good artist, in case you can't tell. Okay, so this is the graph of g of x. In the next video, we'll look at how to come up with the equation of a transform function based on its graph.